Hey everybody, this is Mr. Carey coming back to you with a fresh lesson after our Chapter 6 mid-chapter checkpoint. In this, we're going to be comparing fractions using benchmarks. Now, many of us maybe have never heard the term benchmarks. And if you look ahead, if you turn the page to 260, it'll tell you what a benchmark is. But let's not jump ahead. Stick with me. And we're going to define benchmark before we even really get to it, which is going to be cool. So we have to read the problem. Let's start with unlocking the problem. We're talking about David. Now remember, you know what Mr. Carey likes to do? I like to highlight all the things, all the numbers that I need. I kind of ignore everything else. Half gallon of dried apple rings, great. Okay, did he use more dried apple rings or more popcorn? So that's really... They're giving us two values. They're giving us, and I'll circle them here, 5/8 and 1/2. And they want to know which did he use more of. And so this can be kind of difficult because if, we kind of know what 1/2 is. If I say half of something, instantly your mind goes, right, got it, half. If I say 1, a whole, we know what that means. If I say the number 3, we know what that means. But if I give you a weird fraction like 5/8 or some other weird fractions over here, like, if I said 6, if I say like, 6/9 or 12/16 or, 19/39, right? That doesn't mean anything to us. Our brains aren't really, doesn't know what that means. So that's why we use 1/2 is kind of a good way to measure these other fractions. So let's start off. We're going to use the fraction strips and we're going to compare 5/8 and 1/2. So let's color in, and I'm going to use red. 1/2, all right, and my colorings, I'm not going to color in everything. There's 1/2, and now we color in 5/8. So we're going to count with me. 1, 2, 3, 4, 5. All right, and then now, well, which is bigger? Is 5/8 bigger or 1/2 bigger? Well, it looks like 5/8 is bigger. So we're going to put our little alligator or a greater than sign because 1/2 ends right here, but 5/8 ends right there. So 5/8 is a little bit more. So David used more popcorn. Excellent. All right, so we used more popcorn. So now we're going to get into 1, 2, and 3, right? And now we have to kind of think about what we just did. So write 5 fractions equivalent to 1/2. And I tell my students it's best to memorize, fractions that are with 1/2, at least the first couple, right? So let's start off with 1/2. And then we can go to 2/4. And then we can go, now if you can see, 1 times 2 is 2, 2 times 2 is 4. And let's do 3. 1 times 3 is 3. And then 2 times 3 is 6. And let's do by 4. 1 times 4 is 4. 2 times 4 is 8. And let's keep going. 1 times 5 is 5. And then 5 times 2 is 10. Oh, let's do a couple more. Let's do 6. 1 times 6 is 6, and then 2 times 6 is 12. So there's our first kind of 5 fractions there. And there you go. That's all you have to do. Now, this question, how many eighths are equivalent to 1/2? So let's look here. We have halves, we have quarters or fourths, sixths, eighths. And then if we keep going, tenths and twelfths. Right now I just care about eighths. So how many eighths are equivalent to 1/2? Meaning, what's my number at the top? 4. So I have 4 eighths. Or if you want to write it in longhand, you can say 4 eighths. So 4 eighths is the same as 1/2. And then how, so this is a question that's really good. So we're not always going to be able to draw a model, right? I mean, this is nice that we have the model up here, and we can draw them if we do get stuck. But what happens if I can't draw a model? You just don't want to draw a model. So think about what are some ways right, I can compare 5/8 and 1/2 without using a model. Now think back to what we did before the mid-chapter checkpoint. What were we doing? We were finding equivalent fractions. All right, and how do we find our equivalent fractions? Remember, we use our, what do we use? Greatest. Actually, you don't even want to use greatest. You can use least. That has to be something else. Least common multiple. Remember, least common multiple. Almost got me saying greatest common factor. That'd be something different. So how do we do that? Well, let's start off by, remember, take our denominators, 2 and 8. And now we write our multiples, 2, 4, 6. I'm already jumping ahead to the answer. 2, 4, 6, 8. And let's do our multiples of 8. 8, 16, 24. Really about it. So now, what is my least common multiple? Well, right here, 8 and 8. So remember, with this least common multiple, what does that mean? That means that's my new fraction, right? That's going to be my new denominator. So I already have 5/8 is equal to 8, 5/8, and I have 1/2 is equal to 8. So now what do? 2 times 4 is 8, so 1 times 4 is 4. Now, how do you explain this in words, right? Because, again, I'm just kind of doing a little review here, but if you just did that on a test or the homework, I would say, right, okay, but explain to me in words. So this is about what I would probably write. I think this would really kind of, like, what do we just do? I would find the least common denominator, least common multiple to find fractions with a common denominator. And that's all you're really doing. That's just what we did. I'm getting my terminology mixed up. Trust me, I know what I'm talking about, even if sometimes my words may not make sense. But, so you're going to find the least common multiple to find fractions with a common denominator. So in this case, 8 is the common denominator, and I would change 1/2 to 4/8 so I can compare the fractions. Remember, it's a lot easier to compare fractions when the denominators are the same. It's just so much easier. So if you can, any chance you can, if you're comparing fractions, make those denominators the same. Cool. Now let's go ahead. I'm going to do a little bit of a magic trick here, and I'm going to, my magic, and I go, and then now I'm going to find my other page, which is page 260, and there it is. Look at that. All right. So benchmarks. We used a benchmark, and we didn't even know what a benchmark was. So a benchmark is nothing more than a known size or amount. It just helps you understand a different size or amount. So we use benchmarks all the time, and you may not even think about it. Right? Some common benchmarks, and I did this in class today. We like to use feet, as in 1 foot. Right? We generally know what 1 foot is. So if I said, oh, he's about 6 feet tall, he's about 10 feet tall, he's 3 feet tall, we know what a foot is. A lot of us use miles. Right? A mile is another good benchmark. If I said it's a mile, now you may not know exactly how far it is, but you don't really need to. Yes, it takes me about this long to drive a mile, or yes, I know from here to there. So a benchmark within fractions, right, is really cool because it's using something that we know, like we know 1/2. If I say half of something, you know what that means. So you can use 1/2 as a benchmark, and something they don't tell you here, you can also use 0. I'm going to draw a little number line here, and I'm going to jump ahead a little bit, because that's what I do, right? Here's my first benchmark, 1/2, and then my other benchmark is 1. So these are all benchmarks we can use. If I said 0, you know how much 0 is, it's 0. If I said 1, you know how much 1 is, 1 of something. If I said 1/2, you know what half of something means. You know what that means. And that's all we're doing here. So let's use our example to compare fractions, right? A family hiked the same mountain trail. Got it, right? This is where you do Mr. Carey and you just kind of ignore. You just say, got it. Evie and her father hiked 5/12 of the trail. Jill and her mother hiked 9/10 of the trail. Who hiked further? They both stopped before lunch, right? So the first thing you're going to do is compare 5/12 and 9/10, which is weird, right? If I said I did 5/12 of something, you may not understand what that means. So that's why we're going to compare 5/12 to 1/2. So let's shade in 5/12. We have 1, 2, 3/12, 4/12, 5/12. Now let's compare 9/10. 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10. All right, this is this is pretty cut and dry. We can look at these amounts and go, oh yeah, well 5/12, if I'm comparing these two, right, is 5/12 greater than or less than 1/2? And I'm going to draw my little line here. There's 5/12. That's where I stopped shading. So is that less than 1/2 or more than 1/2? Right, it's less than 1/2. 5/12 is less than 1/2. What about 9/10? Here's my 9/10 right here. Is that greater than or less than 1/2? Oh, that's greater than by like a lot. So this is where we start to use benchmarks, right? We're comparing everything to halves. So since 5/12 is less than 1/2 and 9/10 is greater than 1/2, you know that 9/10 is greater than 5/12. So Jill and Mom hiked further before lunch. That's all we're doing here with benchmarks, right? I don't want you to look at these fractions and just look at the numbers. A few students, they like to say, well, I know, like if I show, they know 9/10 is bigger than 1/2 because 9 is bigger than 1. Again, I don't want you to get into that habit because there's going to be times where it may be tricky and you have to compare the fractions, and just because the top number of the numerator is more doesn't mean that that's necessarily a larger fraction. It may be a smaller fraction. So let's go ahead and look. This is where we're going to kind of piece it together. We're going to get away from the models, and I want you to explain how 5/12 is less than 1/2 without using a model. All right, so something I would do when you're looking at halves, right? When I'm looking at 1/2, 2/4, 51/100ths, whatever, 25/50ths, look at the relationship here. Look at the relationship between my numerator and my denominator. What's the relationship? Right, the numerator is half of the denominator, which is why it's called a half. 25 is half of 50. 2 is half of 4. 100 is half of 200, and so on and so on. So what you should do if you're going to use benchmarks, this is a little tip from me to you. Check out your number here. Look at 5/12. How can I know that's less than 1/2? All right, well, let's look at what would 1/2 be. Now, I'm going to do this. 1/2. If I want to convert that to 12ths, how could I do that? What would be one? I'm not even going to multiply. I just want you to look at the number. What's my bottom number? What's my denominator? 12. What's half of 12? 6. Very good. 6/12. So I can compare 5/12 as less than 1/2 without using a model. And how can I do that? This gets into what you already know. I know that 6/12 is equal to 1/2. Since 5 is less than 6, I know 5/12 is less than 6/12, or 1/2. Easy, right? Pretty cool. Now, what happened? We're going to do the same thing with number 5, which is cool, right? Number 5 is really the same exact thing. All we're doing here is now we're comparing 7/10 and 1/2. Now, before some of you comment below and say, but, Mr. Carey, up here it said 9/10. You're right, but they're just throwing a different fraction to see if you're paying attention. That's all they're really doing. So let's look at 7/10. All right, there's my number 7/10. Now, how can I tell that 7/10 is greater than 1/2? So again, I'm going to do 1/2, and what if I need to convert a half into tenths? How do I do it? Look at my number, my tenths. What is half of 10? 5. So I know 1/2 is equal to 5/10. And this is where you write this, right? This answer I'm giving you is a really good A+ answer. Not just because I came up with it, but it's pretty good. So I know that 5/10 is equal to 1/2. Since 7 is more than 5, do this 5, I know 7/10 is greater than 5/10, or 1/2. And that's it, right? That is how you use benchmarks, right? So for your next pages, which I'm not going to do, you're going to do share and show and then on your own. Don't just look at the numbers and try and compare them. Use your benchmarks. Your biggest benchmark that you're learning right now is, and I'm going to write it really big for you. I'm going to write it like your biggest benchmarks. 1/2. That's your benchmark. Base everything off of 1/2. All right? Is it, I'm like totally going to write over this. Is it less than 1/2? Or is it greater than 1/2? All right? Everything is based off of that. All right, I'll do one quick little example, and I'm gonna have to delete all this, so stand by. Here we go, ready, and one more. Okay, so I'm gonna draw out my number line here. I'm gonna do a little number for you, little number line. All right, and let's do this. All right, there's my kind of number line. All right, there's a number line. Now I'm gonna write, here's 0. Wow, I guess I gotta change the and that, right? All right, let's start off with 0. And then I have 1. I'm gonna put my little points there. Should be hash marks, but I'm gonna use points. And then we know 1/2 is about right there, all right? Base everything off of this, right? If you need to draw a number line. But any fraction I give you, if I say I want you to compare, I don't know, how about 5/20 and 7/10? I want you to compare those two. Okay. Now you may be able to look at them and go, I got it, right? 5/20, 7/10. But I want you to prove it to me, right? What's the relationship? So 5/20, if I'm going to make, how do you know 5/20 is less than 1/2? Okay, so I'm going to write 5/20, and I'm going to write 1/2 right here. I'm going to set this to 20ths. What's half of 20? 10. So I know 5/20ths is going to be, it's going to be about like right here. Right? It doesn't matter if you don't know exactly where right now. That's fine. 5/20ths. And I'm going to write, just because I'm asking us to, I know 1/2 is equal to 10/20ths. Since 5 is less than 10, I know 5/20ths is less than 10/20ths, or 1/2. That's all we're doing, right? We're just taking a benchmark and comparing it to that. We're not necessarily, for this lesson, comparing these two fractions immediately. We're using half to kind of figure out where they are. So let's do 7/10. This will be our last one. I have 7/10. All right. What, and we're going to do 10. What is half of 10? 5. So I know 7/10 is probably going to be about like, I'll just say right here. That'll work. All right. 7/10. And then our response for this, why did we place it there? Well, I know that 1/2 is equal to 5/10. Since 7 is greater than 5, I know 7/10 is greater than what? 5/10, or 1/2. That's it. That is what we're doing. This is just a little extra problem here to kind of get you going. So compare everything to a half. If you need to, draw a number line, or if you can place a number line in your imagination, really, your benchmarks right now, and I'm going to circle this like in like really thick blue so we get it. Your main benchmarks, 1/2. Okay? Now, okay, I told a little fib here. I'm going to do one more because you're bound to come up with these. So I'm going to erase this, all right? And, okay. So, I'm going to draw another number line here. All right, there's my number. Boom. All right, now what happens when I give you a fraction and it's both? They're both below or above 1/2. All right, that's going to be my boom. I'm going to do boom, and then boom, right? So there's my number lines. All right, let's make our little thing smaller here. There we go. There's 0, 1/2, and 1. All right, I'm going to give you two fractions, and I want you to compare them. All right, and this is going to come up a little bit, coming probably next page. Give you a little hint here. All right, so I've got two fractions, and I'm going to come up with, how about something a little kind of fun. Let's do 3/8, and we're going to do, how about 5/12. Now again, I don't necessarily want you to compare these two yet. You're going to compare them to a half first, right? This is like, why do we do this? It's just a quick way that you can, instead of going through and like setting each to a common denominator, it's a quick way that you can look at fractions and go, boom, I know that this fraction is bigger than that. So let's start with 3/8 and we'll figure out where it is. 3/8. Now, this is where it gets tricky. I'm going to actually move this down here because this is where it gets a little tricky. So I know 3/8. And what about a half? Okay, well, what is 8ths? 1/2 is the same as 4/8. So it looks like 3/8 is pretty close to 4/8. Okay. Now what about 5/12? Well, that is equal to 6/12. So 1/2 is equal to 6/12, 1/2 is equal to 4/8. So it looks like 3/8 and 5/12 are actually pretty close, right? So how can you tell which one is bigger? or which one is smaller? How can we figure that out? Well, the biggest thing that you do is which one is closer to the half, right? And this is, I gave you like a really odd example because they're both pretty close to each other. But what you would do is I would take 3/8, and I'm pretty close. 3/8 is pretty close to 4/8. But 5/12 is closer to 6/12. So right here, I'm going to put which one is closer to a half. Now this is where you may not understand this, and it's okay because this is like a really bad example I just came up with. Because 3/8 and 5/12 are both like one away from a half. But because this is cut into larger pieces, 3/8 is actually going to be a little further away than 5/12. All right. So really, but the question is, the overarching question, how can I compare fractions using 1/2 as a benchmark if both fractions are less than 1/2? So how can I do that? How can I compare fractions using 1/2 as a benchmark if they're both half, if they're both less than half? Remember, we are using one is less, one is more. Well, it depends if you're looking to see which one's bigger. If you are looking to see which fraction is bigger, the fraction closest to 1/2 is larger. Or the fraction closest to 0, another benchmark, is smaller. And that's it. You're going to see that in the next page. And that's just to give you a little sneak peek of that. Because you're going to get some of these where both the fractions are going to be here, or both the fractions are going to be here. You're still using half as a benchmark. Still using half as a benchmark, right? If they're both less than a half, whatever one's closer to here is bigger. If they're both over here, whatever one is closer to a half is smaller. All right. So use that imaginary number line in your head, or draw it out if you need to. So this has been chapter 6.6, using benchmarks. And trust me, this will get a lot better in the next coming chapters, only because you're going to have an idea of looking at a fraction and knowing, is it greater than or less than a half? So tune in for my later chapters. We're going to finish up chapter 6 probably this week. So I'm looking forward to being done with chapter 6. And then chapter 7, if you've already flipped ahead, we get to add and subtract fractions, which is super cool. It's not my favorite thing to do, but there's a reason why we make the denominators like 3/8 and 4/8, or 5/12 and 6/12, why we make them the same denominator. So if you like this video, fantastic. Go and comment below, like the video, maybe subscribe to me if you haven't. And if you didn't like it, why don't you just tell me why? I didn't like that you used red too much. I don't like your messy handwriting. Whatever. If you don't like my messy handwriting, I will try and write a little neater, or I'll just type more. But this is Mr. Carey signing off from lesson 6.6. Hope to see you tuned in to my next lessons. See you later.